Section 5.1 is about probability distribution. We will learn what do we mean by probability distribution and how to use probability distribution to find parameters of population or statistics of samples. Now let's start with this overview. In chapters 2 and 3, we learned what's called descriptive statistics. And in those chapters, we learned or we dealt with distributions like frequency distribution. For example, if you have ages here of people who visit some clinic and the frequencies, then if they age from 0 to say to 9, we have 5 people. From 10 to 19, we have 10 people, and so on. So this is called frequency distribution because it's a distribution that's based on frequencies. And here, in this case, we can find, after finding these data, this is past data in general, because we go to a clinic and find some data about the visitors and then, or the patients, and then we start classifying these, analyzing them, and before that we try to visualize them if that's possible, make tables. Frequency table or frequency distribution is one of these powerful methods to visualize these data. And then we can analyze and get some, study some statistics or parameters. For example, we can find the mean, the median, we can find the mod, if that's those are the central tendency measurements, or we can use or we can study the for example, standard deviation, variance, and some other measures. That's what we studied in chapters 2 and 3. In chapter 4, we started learning something about probability. We defined probability and we studied some types of probability like the conditional probability and Bayes' theorem. Now, in this chapter, in chapter 5, we will use the descriptive probability and probability that's learned in chapter 4 to describe and analyze what are called probability distributions. So instead of dealing with frequency distribution, for example, we deal with probability distribution. And by probability distribution, we mean a distribution that includes, instead of frequency, we have probability of some variable, and we'll talk about this variable later. Here we have values of that variable, and here probabilities of that variable. Okay, so this is called probability distribution if it satisfies some conditions. We'll talk about this in this section. So in this chapter, we will construct probability distributions by presenting possible outcomes along with relative frequencies we expect. Okay, let's take an example to summarize. If we want to find number of girls for couples having 2 children. In chapter 2 and 3, we used to make, for example, frequency table, and we collect sample data from families with 2 children, then find statistics and create graphs. And after that, we can find the mean X bar, and we can find standard deviation, we can find variance, so we can find these measures. And in chapter 4, we focused on probability, how to find probability. For example, find the probability for each possible number of girls. So we first, in order to find probability, we find the sample space. What is the sample space of this experiment? We have, let's say, 2 kids. They can be, or 2 children, they can be either boy or girl, the first one, and the second one, if the first one is boy, the second one can be a boy or a girl. If the first one is a girl, then the second one can be a boy or a girl. And then this sample space is boy, boy, both of them are boys, or boy, girl, the first one is a boy, the second one is a girl, or the first one is a girl and the second one is a boy, or the first baby is, or baby in the first birth is a girl, and in the second birth is a girl as well. So these are all possible outcomes. This is called sample space. After finding the sample space, it becomes very easy to find probabilities. Now here we have some events. For example, probability of 0 means probability of having no girls. No girls in that event. So no girls, that means only this choice, this outcome, boy, boy. But this outcome is just 1 out of 4 outcomes. So we can write it as 0.25. So probability 0 girls is 0.25. Probability of 1 girl is, we have 1 here and 1 here. So 2 out of 4, which is 0.5. Now probability of 2 girls is just 1 out of 4, which is 0.25. Now this chapter we'll find these probabilities and we'll describe the event by using what's called random variable. We will use, instead of finding probability of an event, we will use probability of a random variable. So the random variable here denotes number of girls, and it can be 0 or 1 or 2. If number of girls is 0, the probability of that is 0.25. If number of girls is 1, the probability of that is 0.5. If number of girls is 2, probability of that is 0.25. This distribution is called probability distribution because it includes probability here. And we have some variable. The variable denotes number of something, and the probability is the probability that's related to that number. So here, that's what we will deal with in this chapter, in chapter 5. And then from this we can find parameters like mu, that's the parameter of the mean of the population, sigma, which is the standard deviation for the whole population. And we'll learn how to find these quantities or measures, mu and sigma, and the variance. We'll have some formulas for that, but for now this is the idea, that this is what we'll see in this chapter, basically in this chapter, probability distribution and how to find these measures or these parameters from that distribution. So we'll start with the variable x here. We called it random variable, but let's define it here. Random variable, we usually denote it as x. It has a single numerical value determined by chance for each outcome of a procedure. In the previous example, x denoted number of girls, and that number of girls can be 0, 1, 2. So it has some numerical values. So variable that has some numerical values. It's sometimes called function. But let's just use the random variable, and that's it. Now, probability distribution is a distribution that, table or distribution that has the random variable values and their probabilities, corresponding probabilities. And we use it to find population parameters. Now, discrete, we have two types of random variables, discrete random variables, and in that case, we just deal with whole numbers. The values of the random variable are whole numbers. I don't mean that this does not accept fractions. For example, number of sales cannot accept, for example, half. We can say that the sales are 5 and half items. just 5 or 6 or 7. Number of calls, phone calls, we can say 0 or 1 or 10 or 100. We can't have, for example, 1.5 phone calls. People in a line, we just count them 1, 2, 3, etc. So these are discrete random variables because they are whole numbers and they do not accept fractions. And we have another type that's called continuous random variable. In this case, we have infinitely many values, and those values can be associated with measurements on a continuous scale without gaps or interruptions. For example, lengths or depths. For example, if we use centimeters, for example, we have the depth is 0.92 centimeters, or in meters 1.5 meters. So this accepts fractions. So that type of random variables is called continuous. Also weights, time, 2.5, 2 and 15, 13 minutes. So it accepts fractions, volumes. All these are continuous random variables. Let's take an example. In this example, we want to determine whether the random variable is continuous or discrete. Here we have, this is a typo, this should be foot. Exact foot lengths of a human. This accepts fractions, so this is continuous. B, number of tosses of quarters required to get hits. Is this continuous or discrete? Number of tosses can be 1 or 2 or 3 or 4, etc. That means those are whole numbers. It's discrete. C, number of spins of rolled wheels required to get the number 7. Since we are talking about number of spins, that cannot accept half or fractions. So this is also discrete. The last part, response to the survey question. Did you smoke at least one cigarette in the last week? Here, if we look at this random variable cannot be defined here because we don't have specific value related to some event or some random variable. So here the answer is either yes or no. We don't have numerical values here. So this is not a random variable. Now I think it's clear what we mean by random variable and how to distinguish between continuous from discrete random variables. Now we have two requirements for a probability distribution. Now if you see some table, that need not be probability distribution. It's a distribution, but it's not probability distribution. It's just a table. We call it table, and we don't use the terminology probability distribution for that. What are the conditions under which we call that table that consists of random variables and their probabilities? When can we say that this table represents probability distribution? Now we have two conditions here. The first condition is that the sum of all probabilities must be 1. And we use this symbol. Sigma means the sum, and the sum of all probabilities is equal to 1. And the second thing is that each probability value must be between 0 and 1 inclusive. For example, here, look at this example. Is this probability distribution? We'll see. First, the sum of the probabilities. What is the sum of probabilities? It's 0.25 plus 0.5 plus 0.25. So the sum is 1. The sum is 1.0 or just 1. So the sum is 1. That means the first condition is satisfied. The second condition says that each probability must be from 1 to 2 inclusive. So here the first probability is 0.25, it's between 0 and 1, and the second one is 0.5, it's between 0 and 1, the third one is 0.25, is between 0 and 1, so we are okay. So that means this is a probability distribution. If we find the sum and the sum was less than 1 or greater than 1, that means this is not a probability distribution, even though we have random variable and we have some probability. Okay. Now we have an example here. And in this example, we are hiring managers. We're asked to identify the biggest mistakes that job applicants make during an interview. And the table below is based on their responses, based on data from an Adecco survey. Does the table below describe a probability distribution? So let's check the two conditions. The first condition is that the sum of the probabilities is equal to 1. We want to check this. So these are the probabilities. Let's find the sum of them. The sum of them is 157. This is not equal to 1, so no. This is not a probability distribution. And another thing is that the random variable doesn't take some values. It's just description, being late, lack of eye contact, and as you can see, those are not numbers, not numerical values. So this is not probability distribution. Let's look at this one. We have A, B, C, 3 tables. We want to see if they are probability distributions. We need to find the sum of each one to see if they sum to 1. If the sum is 1, then they are probability distributions. Otherwise, they are not. So I'll leave it to you guys to find the sum of these values and to see if the number sum is 1, that means it's probability distribution. Now problem 4, we are preparing probability distribution for the following experiment. So for this experiment, we have, for example, we toss 3 fair cones, and X represents number of hits. So we usually, when we deal with this type of problems, probability distributions, we need first to define the random variable. Let's denote it as RV. RV is X. We need to define it first. Number of hits. So we first define the random variable, and then we want to find the sample space after tossing a coin 3 times, or tossing 3 fair coins. So the first coin can give us head or tail, the second one head or tail, the third one head or tail. Now the sample space is head, 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 all heads, head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, head, tail, 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 head, tail, tail, tail. So how many outcomes are there? We have 8 outcomes. As you can see here, we only have 2 outcomes here, 2 outcomes head or tail, and here we have 2 outcomes. Just multiply number of outcomes in each stage, and that will give you how many elements are in the sample space. It's 8. So this is part A. Now part B, we want to construct probability distribution. So in the probability distribution, we first put a column for the random variable values, and the second column will consist of the probabilities. So here the random variable is number of hits, and that can be either 0 or 1 or 2 or 3 hits at most when we toss 3 fair coins. So the random variable can take the values 0, 1, 2 or 3. And what are the probabilities here? Probability of 0, or sometimes written or probability of x equals 0. This is how many outcomes that do not include any heads. No heads, that means 3 tails. That's 1/8. And for 1, probability of 1 or probability of x equals 1 is equal to 1 head. How many outcomes that have only one head? Here we have 1 head, here and here. So those are 3 out of 8. Probability of x equals 2, or probability of 2. 2 hits, we have 1, 2, 3. 3 out of 8. And probability of x equals 3 hits, number of value of the random variable is 3. We have just 1 that involves 3 hits. So this is the probability distribution. As we can see, the sum of these distributions, for example here, the sum of the probabilities is equal to 1. 1/8 plus 3/8 plus 3/8 plus 1/8, and that's 8/8, which is equal to 1. So the sum is equal to 1, and each probability is less than 1. That's clear by just looking at these fractions. The numerator is less than the denominator. Now, part C, we want to draw a histogram of the probability distribution. So in this case, you put the value of the random variable, for example, 0, 1, 2, 3, and then find probabilities of that. I'll stop for a second to let you think about how to graph the histogram. Okay, now in order to graph this histogram, we put the probability, the values of the random variable here. This is x and this is p of x, the probabilities. And here we put, for example, 0. You don't need to put it here in the intersection, so you can just put it here to the right. And 1, because this is not the xy plane, this is random variable probability plane, so it's x represents just a value of the random variable, and here 0, 1, 2 or 3, those are the values of the random variable. And here we have probabilities. We can put, for example, here 1/8, 2/8, 3/8 up to 1. Now we want to find, for example, here probability of 0. Probability of 0 is 1/8. So we draw a bar here, and then we construct a rectangle. And probability of 1 is 3/8. Probability of 2 is 3/8 as well. Probability of 3, x equals 3, is 1/8. So this is the histogram. This is part C. Now we come to parameters, how to find parameters of probability distribution. I mean, we want to find the mean, variance, and standard deviations. The mean is the sum of the products x times its probability, and we find the sum of these. The variance is denoted as sigma squared, and it's the sum of x minus mu squared times p of x. And if we take square root of that, we get the standard deviation. Now let's take an example. Here we have, in the previous example, example 3, when we toss a coin 3 times or toss 3 fair coins, we have the following distribution. X is number of heads. We have either 0, 1, 2, or 3 heads. We find the probabilities. If we convert these probabilities into fractions using calculator, we get, for example, here the probability is 0.125, here probability is 0.375, here 0.375, and 0.125. We'll use these rather than the fractions. Now probability of x here is 0.125, 0.375, 0.375, and 0.125. Now we need to multiply x value by its probability. Now the answer here is 0. 1 times 0.375 is just 0.375, and then 2 times 0.375, that's 0.75. 3 times 0.125, that is 0.375, and then we find the sum. We add these to find the sum. This expression mu is, the mean is the sum of x times p of x. That means we need to find the sum of these numbers here. This is 1.5. We use the calculator. Now if we want to find the variance, sigma squared, we need this expression. We need to find this to include this expression, x minus mu squared, and then we multiply it by the probability. So let's add this. We first find x minus mu, then we square it, and then we multiply it by p of x. So x minus mu, what is mu in this case? Mu is 1.5. So 0 minus 1.5 is negative 1.5. And here negative 0.5, 1 minus 1.5. And here 0.5, because we have 2 minus 1.5. And here 3 minus 0.5, which is 1.5, which is 1.5. And then we square these numbers here. The square of the first number is 2.25. The square of negative 0.5 is 0.25. The square of 0.5 is 0.25. Square of 1.5 is 2.25. And then we multiply this by probability of the corresponding of probability. We multiply 2.25 by, for example, the probability here is 0.125. We multiply this number 0.25 by the corresponding probability, which is 0.375. We multiply this number here 0.25 by the corresponding probability, same as in the above case, and here we have 2.25 times its corresponding probability, which is 0.125, and using the calculator we get the following numbers: 0.28125. For the second one we get 0.09375, same thing here, and here 0.28125. And we find the sum of these because we want to find the sum, since the formula for variance includes sum of this column, sum of values in this column. So the sum is 0.75. That's the variance. So the variance is 0.75. If we want to find the standard deviation, we just take square root of that. So we have mu, the mean is 1.5 hits, and we have variance, sigma squared, 0.75 hits squared, or we can round it to the next digit. We get 0.8 hit squared because we have square here. And standard deviation, or just sigma, is square root of 0.75, and that is approximately 0.866025, which can be rounded into 0.9 hit. Now the expected value. What do we mean by expected value? The expected value is this quantity, sum of x times p of x. That's the mean. We computed the mean here. This is called, the mean here is called expected value. So the expected value is the sum of x, the random variable, times the corresponding probability. So the expected value of a discrete random variable is denoted as E, capital E, and it represents the mean of the outcomes. Now we have unusual results. We use range rule of thumb. If we have between the mu plus, here's mu plus 2 sigma, 2 standard deviations, mu minus 2 sigma. If the values are between mu minus 2 sigma and mu plus 2 sigma, then those are usual, otherwise they are unusual. If they are here greater than or less than this number, they are unusual. So for probability, we have the results are unusually high. X successes among n trials is an unusually high number of successes if the probability of X or more is less than 0.05. It's unusually low if probability of X or less is 0.05. I mean, if the probability is small and very small, I mean less than 0.05, that means for X or less, that means we have unusually low result. If it's for X or more, it's just less than 0.05, it's called unusually high. Now let's take an example on expectation. Here we have in example 5, we have $5 to place on a bet in the Golden Nugget Casino in Las Vegas. You have narrowed your choice to one of two bets. Roll it, bet on the number 7 and roll it, or craps, bet on the pass line in the dice game of craps. We have two cases. The first one, you have two choices here. The first one is if you bet $5, if you are using roulette, if you bet $5 on the number 7 and roll it, the probability of losing $5 is 37 over 38. So this is probability of $5, positive $5. And this is the value of the random variable. And the probability of making a net gain of $175 is 1 over 3/8. We want to find the expected value if you bet $5 on the number 7 and roll it. So we make a table. So this is for part A. This table is just for part A. And we want to fill this table. So the event is to lose or to win. You may lose $5 or win $175. What is the probability of losing $5? It's 37 over 38. What is the probability of winning 175? It's 1 over 38. Now what is x times p of x? We just multiply those and those. So when we multiply the first row, we get negative 4.868421. And when we multiply the second row, or the values on the second row, you get 4.605263. Now we want to find the expectation. So the expectation is the sum of x times p of x. I mean the sum of the values on this column. So what is the sum of the values? Using the calculator, we find that the sum is negative 0.2626. So we expect to lose an average of 26 cents. Now let's do part B. In part B, if you bet $5 on the pass line in the dice game of craps, the probability of losing $5 is 251 over 495. And the probability of making net gain of $5 is 244 over 495. So here, what is the event? To lose or to win. What is the x, the random variable value? It's here $5. You may lose $5, that's negative 5, or you may win $5. Now what is probability of losing $5 is 251 over 495. What is probability of winning $5? It's 244 over 495. And then we multiply these to find x times p of x. We get negative 2.535353, and here we get 2.464646, and then we find the sum of the numbers on the last row, the last column, x times p of x, which is sum of x times p of x, that is equal to negative 0.07 if we find the sum of those two values. So we expect to lose an average of 7 cents. So which one is better? For sure this one is better, to lose $7 rather than losing $26.